Alright, it's time for another video. In this video, I want to talk about three things. The first one is why does sometimes things that look simple hide a lot of complexity? So that's the first thing that I want to talk about. The second thing I want to talk about is this concept called growing and splitting. It's not an idea that I came up with. It's an idea by Kent Beck, where he talks about how you build something that works, and sometimes it could get larger, and then once it gets larger, you then split it into smaller parts. So growing and splitting is something that I want to talk about. And the last thing I want to talk about is providing targeted context to your coding agent. So these are the three ideas that I want to briefly touch upon. On the screen right now, you're looking at a simple module that I was building for clarity, and you already see that there is a cyclic dependency over here, right? And at this point, you only see that there are like three different types that are over here. But later on, you also realize that as I add more things, like I added a formatter that could format in Mermaid, then another formatter that could format in GraphViz. So if you look at this diagram, the diagram is still growing, but you also see lots of like bidirectional arrows or cycles in this graph. And cycles are typically hard to reason about because if you're tracing data flow from one component to the other, then it keeps going back and forth. So in this case, it's not just data flow, it could also be types that are being shared between these classes. And I've talked about this before. I've spoken about how you create smaller components and then you make the arrows flow in one direction. So that's what we're trying to do. If you look at the next diagram, there's some level of directionality that we have achieved. Like it's the same thing, but then things have started flowing in one direction and you don't see the cycles here, right? And eventually what you see is there's still a little bit of more shuffling around because I keep questioning relationships. You don't have to understand this. If you see a diagram that you are working on for your project or code base, then it would make a lot more sense. And you would ask questions like, why is this connected to something else? Like, why is this testing this other class or type? So eventually you notice that we end up in a state where we have a few tests and then we have these arrows that are pointing in a certain direction. So if you look at the first diagram, it looks a lot simpler and then there are like few things to reason about, but that's not true because some of these types were hiding the types that we extracted later on, right? I don't remember, but I believe the delta.go file had like a lot of things and then which got extracted little by little, until it came to this stage, right? So that's why that covers the first point where I was talking about why things that look simple are not really simple because there are like so many concepts that are put together in one single file. And once you start extracting them out, then you see all the different pieces and how they fit together. So that's the first concept. And the second concept is again, like, if this delta.go is probably like a very large file at this point. But if you see, now we have split it into smaller things. And that file probably, in terms of how the tool worked, it was doing its job. It was doing what it's supposed to do, right? And there's nothing wrong there. And this says when you have a larger component, then it becomes it gives you a false sense of belief that the component is simple and it's easy to reason about, but in fact it's not. Like even the single file has decomposed into so many other smaller components. But even though this looks a bit complex, it's a lot more easy to reason about because you can see them right in front of you. And this thing, right, like where you have a very large component and then you split them together, they give you smaller components that you can reason about. So which is, again, like you grow the component first, you make it work, and then once it works well, then you start splitting it, right? So that's the second concept. And the third one about providing targeted context. In this case, if I were to extend the feature or make a bug fix in that one particular file, then I would tag the entire file in my coding agent's chat conversation, and then I would ask it to go fix it, which means it becomes very hard for me to give context or like give relevant information because one, I don't really understand the system because to me, it just looks like one single file. And the second part is the LLM has like information that may not be relevant, which makes it less effective because you're giving information it's not relevant to the current problem. When you split your components into like smaller pieces, then when you're tagging your coding agent, if you're tagging a certain file with your coding agent, it gives you an opportunity to be a lot more precise about what you're talking about, right? So having an understanding of the system that you're building and also being precise about things that you want to do makes it a lot more easier for large language models. And that's why it helps to have smaller things. And when you also have smaller things, it also becomes a lot more easier to test these smaller things by writing tests. That covers it. So I believe we talked about three things. One is how simplicity can actually hide a lot of complexity within it. The second thing I talked about growing and splitting. So you can build larger components, but then when you get to a point where it is working, but you want it to be more maintainable, you start splitting it into smaller components. So they're easy to reason about. And when they're small, it's also easy to write tests for them. And the last thing I want to talk about is the targeted context part of it. When you have smaller files, smaller components, it's easier to target them in your chat conversation and give relevant context to your large language models. That's all there is. And if you are wondering how I went from this to this, it's basically there is not a special workflow. I just have my coding agent. I also have Clarity on one side. And then I just keep asking the coding agent about the relationships. And if I find something out, then I would ask it to extract them. So the communication is all very high level. So there's no very specific workflow. All I want is to look at the diagram in one Clarity's watch window and then tell the coding agent what to do and where to go next. That's all there is to it. If you have any questions, I'm more than happy to answer. Thank you very much.